The primary role for a robot is to position a mounted tool relative to a part in front of it to carry out a value-adding action. To achieve this, setting up a robot correctly and quickly is essential for automation deployment. After physically installing the robot, the next major stages are setting tool center position, TCP, and part frames. The TCP is critical for the operation of the robot. It is a definition of the position and orientation of the tool, and once set dictates how the robot interacts with its environment. Traditionally, it is set using a pin-to-pin method, lining the point to a spike by eye and rotating to different orientations. This is only as good as the person conducting it, and reproducibility between operators is poor. There is often no record of how well it was performed and what residual error remains. All subsequent programming is reliant on a good TCP, so if it is not set up correctly, considerable time can be wasted touching up and reprogramming the scene. A standard approach can be achieved using a Renishaw RCS L-90 ball bar, which provides a quick and easy method to set a good TCP. This provides consistency across staff, traceability of results, and an understanding of residual error caused by the robot itself. Additionally, this setup activity can be recorded once and reused countless times as the cell and sister cells are rolled out to manufacturing sites. Once the TCP is set, other coordinate systems within the cell need to be defined to describe where objects in the cell are situated relative to each other. These part, user, and object frames effectively describe what is in front of the robot relative to it. Like TCP, the pin-to-pin method is traditionally used to set part frames, which is manual, difficult, and time-consuming if multiple frames need to be set. This inefficient approach can add inaccuracy to the cell. Without accurate part frames, collisions are more likely, offline programming impossible, and additional time is required for on-site programming. Additionally, if the cell is transported, considerable time can be spent reteaching the frames. Using the RCS L-90 can speed up and simplify the creation of part frames. The RCS L-90 kit contains everything required to quickly complete these activities, and the user is guided step by step in the accompanying software. Temperature changes in the environment will make materials shrink or grow. So to ensure the most accurate measurements, the RCS L-90 ball bar can be calibrated to a known length using the included calibrator. This can quickly be carried out before any operation. A neat trick of this calibrator is tied to its design. The ratio of the aluminium to carbon fibre corresponds to the inverse of their coefficients of thermal expansion, so any growth in one material is cancelled out by the other material in the opposite direction. This means the distance between the balls remains the same when calibrating. The RCS L-90 ball bar kit is essential for any integration staff to consistently find and set robot TCP and part frames, both within their own working facilities and on the road when complete cells are installed at their final location. Produce good frames, enable simpler offline programming, and set up once without needing to reteach during the final installation.